Hello, mister. Can you listen?
I'm here.
Okay. So most of participants are from Lexham. Most of the participants are from Lexham, right?
Yeah, at this point, we are hoping people can come in.
Mm-hmm. It's okay.
We
I want
have
to say greetings. All of you are fine, right?
actually we also stream this to YouTube, so some people reach us through YouTube.
Oh, okay.
Yeah, and that's also go to Facebook as well. Yeah. Yeah.
Okay.
Reach our sessions in YouTube and also Facebook.
Okay.
Yeah. Sincere.
Yes.
I would like.
Hear you.
Can you hear me?
Yes.
I would like to start now. Hi, a very good afternoon to all participants. My name is Tae Kim Hong, the moderator for this session. On behalf of the Center Director, the Deputy Directors, and Senior Rexham, we would like to welcome all of you to this webinar series on this course in Science and Mathematics Education. This is the third webinar sessions of the series. The sharing for today is on mathematics with the title Developing Computational Thinking in Mathematics Classroom for the Era of AI and Data Science. Let's begin the session with some ground rules. After you join us, please mute your microphone when you are not talking and press unmute when you wish to talk. Don't forget to use the chat box if you have to ask some questions, make comments, or chat with other participants by changing the chat box setting. In the Q&A session, you may write in the chat box to raise your questions to the presenter or the moderator, or you can even talk directly by unmute the mic. The presenter for this session is Professor Dr. Masami Isoda, who is the Director of the Center for Research on International Cooperation in Educational Development, which we usually call CRISEC, in Tsukuba University, Japan. So Professor is in Japan now. Professor is no stranger in the international mathematics community. Besides his contribution as an academician in the university, he has been the author, co-author, editor, and co-editor in many publications such as Mathematical Thinking, How to Be in a Classroom, Lesson Study, Challenges in Mathematics Education, Japanese Lesson Study in Mathematics, and his contribution in the Japanese primary and secondary textbook published by Gakko Tasho. Professor Masami is a project proponent of a lesson study project funded by Apex, and he has extended his current involvement in projects on computational thinking and statistical thinking, which is the current things that we are learning now. And in this project, the title of this project is called Inclusive Mathematics for Sustainability in a Digital Economy. Besides that, he also played a very significant role as consultant in mathematics curriculum development in countries such as Papua New Guinea, in Indonesia, in Peru, and also have senior in the publications of curriculum document called Senior Common Core Learning Standards in Maths and Science, which is published in 2017. Currently, Professor Isoda is actively involved in the publication of another series of guidebooks entitled Mathematics Challenges for Classroom Practices based on the CBS Common Core Learning Standards, which we expect to be published in January 2021. So he has a long string of involvement. If I were to list down all, I would take up all his 1 hour. So I should stop here, and I will say welcome, Professor Isoda.
Thank you very much,
Yeah.
Steph,
And I
for introducing me. And nice to meet you for everyone. Now I would like to begin my talk. Just wait for a while. The screens are shared or not shared?
Yes, we can see.
Okay.
Yep, it's on.
Okay, now shared?
Yes, good.
Okay. Okay, the title of my talk is Developing Computational Thinking in Mathematics Classroom or Era of AI and Data Science. Your CPU used in I? What use is it? Okay, and the era of AI and data science, and based on APEC Inside project. Okay. So today I will talk about three things. Firstly, the humanity and digital competency or reformulation of 21st century skills. You well know that Star Trek Picard versus Borg. And Picard is the hero for the humanity. So humanity is necessary for digital competency because we use the AI and we making the decision on the necessary situation. And secondly, education for AI era, design thinking for STEAM education. And in these 20 years, STEAM education has been enhanced, and currently more focus on humanistic informatics design on STEAM education. I will talk about this topic secondly. And thirdly, I will provide the I will explain the computational thinking with exemplars. So firstly, the humanity and digital competency. And in APEC project, we discuss a lot of this point. And firstly, in the new world, it is not the big fish which eats the small fish. It's the fast fish which eats the slow fish. What is necessary in current era is a fast reform. And another thing is that algorithm and humanism, both of the necessity to make possible the fourth industrial revolution. And the OECD defined the competency for successful life and well-functioning society. And the CMA standard, year 2017, it was already mentioned by the step. And this is related with the mathematics and science are tools for overcoming the challenges of diversity in Southeast Asia through developing the competency for competitiveness and understanding others for creating a harmonious society. For creating a harmonious society, it is related with humanism. However, the changing the society very fast, it is related with in relation to the competitiveness. And on both perspectives, we developed the CML standard. And this is an example how job changes in the case of Japan. In the case of Japan, this is a report of year 2015. And the year 2013, it expected that the cashier, 99.7% of the job can be alternate to the AI. And in average, 49% of laborers become the task for AI and robot and so on. And the cashiers are 99.7, and on the other hand, barbers 1.2%. So there are many jobs can change, but there are still jobs cannot easily change. One of the points is artistic, humanistic job. At the same time, we have to create the new job on this alternation. And the hotel room clerk, the case of hotel room clerk, 98.7% can alternate. This is an example, the case of Japan. This is a front lady, and at the same time, in the case of Japan, there are this is the automatic check-in machine, and we can alternate the job to the machine. The hotel front lady and room clerk. And on the other hand, this is a tradition of Japanese hotel, but and take caring the people and hospitality is very much important for the hotel work. On the other hand, if we alternate the job to the machine, people feel uncomfortableness. Then how shall they change the job? And they change the job to the guide or the customers. They provide the guide for the neighbors of the neighborhood of the hotel, and they walk around and then show the cultural activities of the people. This is their daily job is basically the merchant. On the other hand, as a part of their life, they are engaging in the art like this. So this kind of activities provide a new job for the hotel room clerk. So how shift the job more humanism job is one of the part. And at the same time, we can do many things can be alternate. And this is a case of the entrance exam of Japan. That the project can AI pass the University of Tokyo exam. University of Tokyo exam is that the score is 7.9, and it means that only 0.5% of student, only 0.5% of student can come into can pass the exam. And AI can the exam task for the private and national universities are different. In the case of private universities, on this project, the scores of the AI is like 65. 65 is around here. Okay? So 84%, other part, 84% of the university, AI can pass the exam. On that situation, what shall we do? We have to change the exam, yes. And how? Such a thing is a current necessity of education, reform of education. And Dr. Habiba, permanent secretary of the Ministry of Education, Malaysia, explained in APEC that the framework for the APEC 21st Century Skills and Competencies framework she provided on the APEC. And there are three pillars. One is soft skills, include leadership, communication, collaboration, global awareness, and so on. And hard skill, mastery of language, digital and ICT skill, and so on. And cognitive skills is critical thinking, problem solving, and so on. So such a competence is a necessity on this curriculum reform. And this is the framework for the computational thinking. There are three pillars. One is algorithmic thinking. It is the programming. On the current curriculum, I believe that every country is trying to put in the programming. It is related with algorithmic thinking. At the same time, computational models and machine learning has been enhanced for the AI era. And computational thinking is known the competency for the problem solving with using the computer. However, computer itself are embedded everywhere, not likely the keyboard. So computational thinking is currently without using computer we are using. And what kind of the computational thinking are important? So that is three pillars. And any subject have some aspect of those things in general. And so for every school curriculum can be form by using those ideas. And at the last moment of today's talk, I will show the exemplar. And this is another framework in relation to the computational thinking. It is statistical thinking. And data science, one of the keywords is data science. And another keyword is Bayesian statistics. And if I begin to explain the Bayesian statistics, it takes one more lecture. And Neyman-Pearson statistics is current school curriculum statistics. So current school curriculum statistics and other ideas are the pillars for the statistical thinking. And the necessity of the form of statistical thinking is related with the difference of big data approach and PPDA cycle by the problem solving for the by using the Neyman-Pearson approach. On the PPDA cycle, we usually begin from the problem, plan, and data. So gathering the data collection is based on the problem and the planning. So this sequence is normal. However, if we use the big data on the smart home, we never think problem and plan. Just begin to use the data. And for knowing the data science, we should know the 5V. One is volume, huge, and variety. For example, there is the map, and the map can be embedded in various information, such as restaurant and so on, and the menu of the restaurant and so on, and the evaluations of the restaurant. And there are, for going to there, map provides us the route. However, how crowded and how long it takes. Such informations are embedded. And the users also, by using the software, Google Map and so on, we can provide the data additionally, automatically. So, and that is the big data, and the data can add, and at the same time we can use. And that connected data is not consistent statistically. Just it is connected, just connected, not statistically discussion on the Neyman-Pearson. Data gathering is after problem and planning. That is Neyman-Pearson approach. On the other hand, big data is not such a way of using the data. Okay, and velocity and the values. Okay. Doubt. Okay. We are not sure that Google Maps information is totally correct or not, because someone added for the sum profit. Okay. Okay. So this is the PPDA cycle. It is necessary for actually the current statistics are embedded in AI. To produce the AI system, we should use the statistical theories and so on. However, when we use the data, it's big data. It is not begin from the problem. It begins from something here, and it's including this kind of activities, patterns and the relationship from data, and the questions, and think about objective, and the data mining. We can find various data, and then understanding and designing something. Okay. So this is the data science, and anyway, because of my title, there are mathematics, and it is related to these issues. Every countries, there are some document existed. Not every, some of leading countries have the document for the necessities and the importance of mathematics or the informatics and data science and so on. For developing the AI and so on, mathematics is necessary subject. But AI enable us to use mathematics more easier. But we need the ways of thinking. So, as I mentioned, there are two issues. One is humanistic social competency by using computational thinking. And another thing is the component to develop computational thinking. For developing establishment of the new society under the fourth industrial revolution, there are people who lead, and many people's work, and even they don't feel we are using the computer, we are using, because there are something have the embedded the CPU and connected to the line on the internet. So competency to lead. So those three are necessary competencies. And another thing is the three pillars. One is programming, another one algorithmic thinking, and one is modeling, and another one is using big data and using AI machine learning. Okay? And another one is AI. Okay. So I will provide the example later. And the competency for programming is included to analyze the problem situation into the component and recognize the sequence of tasks or programming, find algorithm or recognize existing algorithm there and integrate it as a system. This kind of thinking. And the competency for modeling by using existing model of mathematical science, develop the system or generally applicable. And the structure on the problem situation which can apply it, adapt the existing algorithm to the situation. So based on mathematical science, we use the modeling. And the third one is AI and machine learning. And to develop appropriate AI system by using appropriate selective exemplar or data or the specific objective, or just use AI system, not selected data through the connecting the database, utilizing these AI system with programming and modeling. Okay, so those three are the three pillars for the computational thinking. And I would like to mention the STEAM and the STEM education. And I would like to begin from the reform story of the MBA. MBA program currently existed everywhere in the world. And it enhanced business science with computational thinking. It includes analysis, logic, and reasonableness with data for management. The problem is current economic growth is that most of the countries' economic growth is very slow. One of the difficulty based on the existing MBA program is commodity. Anyone studies the same things, commodity, then produce a similar solution, then not innovative and creative. That is the largest problem. And there are some other issues. And Financial Times says that the art school MBA that promote creative innovation. Why? All market in the world directed to the expense for self-realization. Humanity. Humanistic aspect is the key, and self-realization is the key. On that context, art, plan, craft, do, and science check. Such a component increase the necessity. Then there are reform of MBA program. Logical thinking, critical thinking, those parts are related with computational thinking where logic, precision, mainly right side brain check the logical truth subject to objective, various perspectives. This kind of things, logical thinking and critical thinking are related with where computational thinking. Of course, computational thinking is current, old-fashioned computational thinking. And the current computational thinking includes the designing. It is related to more humanity, intuition, heuristics, and brain and five sense, and led by idea-driven and hypothetical. Okay? So this kind of all perspectives are necessary for the new MBA program, and it is ongoing in the process of the reform now. And such a movement established by John Maeda, not only one person, but he did. And he graduated MIT, and he was a professor of the MIT. And he took PhD in our universities, and he shifted his on the MIT. His research is designing by using computer, and he took PhD on art at my universities. And after he go back, he headhunted from the Rhode Island School of Design. And as the president, he engaged the reform to STEM education to STEM education to STEM education. And he worked with the National Caucus with parliament members for the reform from STEM to STEAM education. And there are various movements, and you know that smartphone can work as a, how do you say, ocarina? Okay? Such a things are also innovation, and such a things are related with the five sense. Okay? So human activity. So the AI and computers include more humanistic activity, enable us more humanistic activities. Then this is a Stanford School of Design and design thinking process. University of Stanford enhancing this framework. It is well known the framework for the STEM education. Emphasize, define, ideate, and prototype and test. Anyway, all of those things are related to the humanistic challenge. Of course, they are using computer and so on. And on this context, I would like to see again and visit again the CML Basic Education Standard, CBASE, Common Core Regional Learning Standard, CCRLS, CCRLS, mathematics and science. And this is the framework for mathematics. Okay? It has the three pillars. One is content. This is a hard skill. And mathematical thinking and process. It is related with the cognitive skills. And mathematical value, attitude, and habit for human character. It is related with soft skills. And those things are divided into three. One, mathematical thinking and process is divided into three. One is ideas. Second is the ways of thinking. And the third one is activity. And mathematical value, attitude, and habit for human characters are divided. Values, attitude, and habit of mind or citizen to live. So, what we enhanced on this document was that the content can be acquired through the training. However, ideas, thinking, and activities, and values, attitude, and mind, habit of mind cannot develop without reflection. It means that for reflection, we have to have the process. And reflection of the process and appreciation on the from getting appreciation after reflection. Such a process are very much important in mathematics classroom to develop 21st century skill. And I would like to revisit those framework from the computational thinking. I will show the example. The example is develop computational thinking through robot programming. This is also a joint project with Rexam, and this is a case of the Konkan universities. And can we see the motion? Okay. Still moving? Oh. Okay. Okay, this motion is this program. And as you know, this is visible programming by using the Scratch. And competency for programming is analyzing the algorithm. Okay, it includes the programming that related with the algorithm. And the competency modeling is related with designing. Okay, and I will show the process of development. Firstly, excavator, plan the excavator's design, and then from the block parts we have to develop it. Okay, and at the same time we have to think about the program, how it moves. Okay, then after development we have to check how it works. And on this process, there are translation between the photos, images, and the robot. No, robot means that block robot. And and we have to develop program on computer and send the program to the CPU in the robot. And then check the motion. So on that process, there are various types of translation. Oh, it is not good, we have to change this. Oh, the motion is not good, then we have to change this. Is that the same image? Maybe, no. Then we have to change the name of this robot. Okay. So such activities, translation and interpretation, are very much important activity. And such activity is the same as algebraic calculation. In the process of algebraic calculation, we interpret and imagine how shall we change. And another thing, if we develop the program, there are various different models, okay? And if we have the program, we know how does this excavator can move. But other block models, and we can apply this program to there and there and there, everywhere, anywhere. One program can work any component. However, when we apply, we have to imagine how it moves. Okay? And without before the putting the upload the program to the every CPU, we can imagine how does it move. Why? We learned from this how move, and then the different motors, how when it moves, those are commands. We can imagine how it moves. Okay? And depending on after we apply, we change somewhere a little bit or the appropriate motion. Such activities. So the program itself can work as a model. Okay? So programming activities are related to produce the algorithm. And if we acquire the algorithm well, we can apply the model, other cases. It is actually the same as mathematics learning. When we produce some equations or operations, it is depending on some situation. However, it can be applied anywhere. Okay, it is the same thing. So I will repeat mathematical thinking again. Those components of mathematical thinking can be applied on the programming activity and modeling activity. Okay. Firstly, the exploration and inquiry, modeling, conjecturing, and the representations. There are different representations, and we have to control the other representation by the program. And algorithm is a part of the mathematical ideas. And the translation is necessary activity. And the thinking forward and backward, we do a lot for developing. And after we develop the program, it can be worked as a software, and it is useful and efficient. Okay? Such a things are all embedded in and can be seen from the perspective of mathematical thinking. And lastly, I will show the example for the machine learning without computer. It is very much simple. For the teaching machine, there are two ways. One is provide appropriate examples. To provide appropriate examples, we have to produce a number of appropriate examples for machine learning. And the other way is just driving the car and automatically machine learn. Okay? And there are good driver and bad driver and so on. Okay? So for the appropriate machine learn to produce appropriate AI, we have to provide the good example. And we have to know the way to provide a good example. So could you read this? Could you solve this? Okay? There are conditions. 4 conditions are written to find the path. And it's under a book. There are 3 books. It is not at home, but it is not at home, also outside, here somewhere of these. And under 3 books, it is near the duck, and not near the duck. Which one? And not up of the tree, not here. So near the duck is here. Okay? So this is problem solving, and there are many vacant. Please produce the questions by using 4 conditions. Okay? And find something. So if we know the condition well, we can provide the good examples for machine learning. So such a competency is necessity. And it is including the idea of set and condition. Okay, set. Outside of the school, outside of the home or somewhere. Okay? Condition, it is a condition. And under a book, or there are 3 books. Okay? So it is related with the set and the condition. So such a ways of reasoning are very much important for machine learning. Okay. To teach machine, we have to provide the appropriate example. For that, it is necessary. This kind of activities are necessary. Okay? This is example for the machine learning. And actually, it doesn't use the computer here. It is a necessary human competence to provide the appropriate information logically. Okay. So this is I explained all 3. One is the programming, and one is modeling, and one is the AI, machine learning. Okay. Then more classroom example. Actually, now we are developing the 3 books. Furthermore, math classes. Those books are the set of the task for the teachers and the student. For teachers, most meaningful. And those tasks provide the ways of thinking mathematically, and it means that it will be useful for the computational thinking too. That's really, thank you very much.
Okay, thank you, Sensei. At this point, I have a question. The question is big data equivalent to universal set in the Venn diagram?
Big data?
Yeah.
This one?
Yeah, there's a question from our participant here. Yeah, the question is big data equivalent to universal set as what we learned in Venn diagram?
Big data.
Yeah.
There are various types of data existing. And the various types of data can be connected by using matrix and so on. And connecting the data can be connected. Any data. One is every data sheet can be show some vector, and additionally different vectors come. If I can explain the likely metaphor, and it can connect it. On the Google map, there are various types of different types of data coming in. Visible data, visible data is usually two-dimensional data. And the information for the menus are written on the spreadsheet, and the menu of the spreadsheet it is connected to the photos. Such a things are connected. That is the big data.
So, meaning to say that is big data a universal data set, a universal set.
Universal data set.
Yeah. Okay.
I'm sorry, I don't know the English of the universal data set.
Oh, okay.
It is discussing about the format of the data.
No, it's actually just the terminology. Because, yeah.
Uh-huh. Sorry. I do not know the English word. So anyway, the 5V is the nature of the big data. 5V. Okay?
Yeah.
And we are not sure that the connected data is the chosen the same condition. Some data has the, for example, on the Twitter and so on, only some people replied. In the case of Japan, very few people. We don't have the custom to do such a things. So very few percent of students, and not the student, the people participated in, but it looks like some political issues. So many people say something, but the only few people participated in. So the nature of the big data have those components.
Okay, thank you. There are many participants here. If you have any questions to raise or to ask Professor at this time, feel free to unmute your mic and you can just ask directly or you just type in the chat. I think a convenient way is to unmute and ask the questions. Hello. Everybody is keeping very quiet. Dr. Tiong? No response. Or maybe since then you can go to the chat and see some of the questions here.
Uh-huh.
Yeah, in the chat, there are some questions. Do you get it?
Yeah, just wait.
Yeah.
How can I see the chat? Okay.
Do you get it?
Okay, on the chart,
Yeah.
big data must be in the same condition. Oh, that means the universal data, but not the same condition, because statistically not the same. On the Neyman Pearson approach, data should be gathered against the problem. Statistically, big data must be in the same condition. That is universal data for us, but that is the data science. But in statistics, in current education, we are teaching Neyman Pearson statistics, and it is an approach. Firstly, problems are given, and plan the gathering the data and a set of questions, and take the data in the classroom, and such a data is fixed under the same conditions. Otherwise, we are not easily to compare under the random sampling. So big data is not the data like the statistical analysis by the Neyman Pearson approach. On the other hand, I forgot the word, English, just wait. Bayesian approach is possible to how to say, to know the future possibilities by using the idea of likelihood. And likelihood is related with the I forgot the English word. Likelihood is related with the likelihood. More easier term. There's a more easier term, but I know in Japanese or in English. Okay. Likelihood.
Okay. I hope Professor answer your questions, Mr. G. Before we end these sessions, actually we can have more Q&A sessions, but before we end, we would like to have a photograph taken for the participants here. So may I request that you turn on your video so that we can have a picture, a photo taken. Everybody, please turn on your video. Oh, that's good. Mr. Chan, welcome. Dr. Wara, hi. Dr. Tiong, hi. Oh, nice to have you. Miss Ern, these are some of the old friends. Please turn on. We love to see your faces. Everybody is feeling a little bit shy, but it's fine. We'll get used to that. Zara, Sabaya. Yeah, please turn on your video. We hope to see more. Oh, welcome Sabaya. The other day you joined us. Thank you very much. Who else? Anna, Hasrim, Mr. Ahmad. Okay. Oh, Cikgu Jana. But there's no, cannot, yeah? All right. So we shall have a photo. Let me count. Let's count. Professor, maybe you can take, yeah, you come forward. Yeah, because somehow with the background, we couldn't capture it properly. Yes. How come there is no head? I would suggest, okay, we take this one first. 3, 2, 1, cheese. Oh, good. Professor, wait, one more. We try one more. Oh, Professor, can you change your background? Turn off the video? The virtual background. Sincere, turn off the virtual background. Do you get me, Sincere? Professor, change your virtual background to your room. I think we can see you better. It doesn't hear, I think. Oh, it doesn't hear. Never mind, we try again. 3, 2, 1, cheese. Okay, thank you very much. And if you have more questions to raise, you're welcome because we still have a few minutes with Professor Isoda. Just feel free to have these interaction sessions. Ask whatever questions you want. This is a golden opportunity to get him to answer your questions. Mr. Chan. Any question, Mr. Chan? No question. I'm sure Dr. Tiong has a question or two. Dr. Tiong. Yeah. He turned off. Dora, you have a question?
Okay, it's okay. Thank you very much for the participation, your participation. And I'm looking forward to see you in Malaysia next time beyond the COVID-19. And actually the Asian statistics, all data of the Asian COVID-19, most of the data of the COVID-19 are analyzed by the Bayesian statistics. Anyway, there are any questions?
Okay, if there are no further questions, I have a request that for those who participate in our session, we would like you to capture this QR code and this QR code will link you to some questions which we use the Google form, and we like to get some feedback from you so that we can see where is the weakness or where are the things that you know, some of the comment you would like to share with us, that the feedback enable us to improve our programs, or if we can have any request, do tell us, and we can put up more of webinar sessions. So do help us to give us some feedback. And before I close this session, I would like to say thank you to Professor Masami Isoda again, and to each and every one of you for your participation in this webinar. I hope what you learn, or I hope you learn something new and able to carry back to your classroom and share that in your lectures or in your teaching. And thank you again to participate in this program, and we hope that we can plan more of these sessions to benefit all the educators and all the teachers. So stay safe and till we meet again. Bye bye.
Thank you. Thank you very much, Mr.
Yeah, we hope to meet you very soon.
Okay. Thank you.
Yeah.
And thank you very much for the staff of the supporting people. Thank you very much.